Welcome to Coach Eichner Math. Today we are talking about more points, lines, and planes. Important facts about these things. 2 points determine a line. 3 non-collinear points determine a plane. 3 non-coplanar points determine nothing. That is not important to us because 3 points define a plane. So it is impossible to have 3 non-coplanar points. Now, if you added a 4th point, you could have non-coplanar points, but with 3 it is impossible as 3 define the plane. The intersection of 2 lines is a point. The intersection of a line and a plane is still just a point. The intersection of 2 planes, however, is a line. So let's look at a few things from this picture we have drawn. Notice in example 1, we have plane R with 3 coplanar points X, B, and Y, and a line going through that plane intersecting it at point B. So I would say that X, B, and Y are coplanar. I could say that A, B, and C are collinear because they lie on the same line. Plane R and line AC intersect at point B. Ray AB and ray BC, notice the same endpoint, creating a line because they're going in opposite directions, are opposite rays. X, B, Y, and C. X, B, Y, and C are non-coplanar. Notice, like I said earlier, 3 points are always coplanar, but by adding in that 4th point, you can say that some points are going to be non-coplanar. My suggestion to you is you pause the video at this time, look at example 2, give it your best shot, and then turn the video back on to just go through the selections with me. Alright, looking at example 2, part A, are points S, O, Q, and M coplanar? Why or why not? S, O, Q, and M. Well, I know that Q, O, and M are all on plane T, but S is not. So are they coplanar? No. Why? Because point S is not on plane T. Name the intersection of the planes LON, LON, this plane, and NQM, NQM, this plane, and then explain why. Notice the 2 planes are like having 2 sheets of paper held together. There's one spot where they intersect, and it is that line known as NO, or it could be known as ON, or UN, or UO. Notice it's important that we only name 2 points even if a line has more than that. So we have named the intersection of those 2 planes. Moving on, name the intersection of plane LON, LNO, and line MN. Okay, so notice up here we had 2 planes. 2 planes intersect at a line. Notice a plane and line intersect at a point. So, since it intersects at a point, we're looking at it, and they make it real easy on us, because seeing as how N is a part of my line and N is a part of my plane, LNO and MN share the point N. So they must intersect at point N. Part D, do S and M determine a line? Why or why not? Well, S is out here, M is in here. Do they determine a line? The line is not drawn. But, yes, any 2 points determine a line. And I could draw a line, and use my ruler here to help me. I could draw a line from S to M, and there's nothing stopping me from calling that line SM, because any 2 points create a line. So be careful, S and M determine a line, it is just not drawn in our picture as it crosses through several planes. Part E, name the intersection of line UO and line MN. Again, 1 point of intersection at point N. We talked about it on the other side. 2 lines intersecting at a point. Lines intersect at a point. So that is example 2. Now take a minute, see if you can figure out example 3. My challenge to you is to pause this video, take the time to work through these and see if you can do them without help, and then turn the video back on to double check your work. All right, example 3. Name 3 points that determine plane J. Plane J is my plane right here. 3 points include the 2 points on the line of intersection, point V and point W, and the 3rd point on line J that separates it from plane K is point Z. B, name the intersection of planes J and K. The intersection, as we just talked about, is the line that goes through both. In this case, I'm going to call it line WU. Could have named it any number of things, from VW to WV to UV to UW to VU. Any of those would work. Any 2 points on the line would work for that situation. Looking at the next piece, part C, name a set of collinear points and a set of non-collinear points. So, looking at our picture here, I would say that point U, point V, and point W are collinear points. Why are they collinear? They all lie on the same line. Non-collinear points would be an example of point U, point W, and point X. Point U and W are on a line together, but point X is not, which makes them non-collinear. Part D, name a set of points other than those in A that are coplanar. Well, in A we talked about plane J, so let's talk about plane K. What 3 points are on plane K? We've got point V and point W and point Y. And now to take it a step further, we said that planes go on forever, just like lines. So I could consider that even though this plane has an edge right here, it goes on forever up and it goes on forever down, just like plane J would go on forever up and forever down, which means that anywhere along this line would be considered on the same plane. So I could even say that point U is a 4th point that is coplanar with V, W, and Y. This is the end of Points, Lines, and Planes, Part 2. Hope you've enjoyed, and have a good day.